This graph analysis super FRQ is designed to show you all the possible questions that could be asked on a free response question. Normally you would get 3 to 4 parts, but not knowing what they are, we just have to prepare for anything. So in this question, I'm given the graph of f prime consisting of segments and a semicircle. And I'm asked to write an expression for f of x that involves an integral. To help make sense of how we're going to answer A, I'm going to pull out this end position problem that we had done back when we did motion. So we said our position at B is some known position plus the integral from A, notice that lower limit matches to B, matches the upper limit. What belonged in the integrand was the derivative of position, which was velocity. I'm going to follow that same format as I write my expression f of x. Let's move this down here. And what I'm going to do is f of x, some function value at x, equals some known function value. And what I know is that f of 2 is 3, so I write f of 2 here, plus the integral from 2, my lower limit matches, to x, my upper limit, and what belongs in the integrand is the derivative of f, which is f prime. So even though this isn't a motion problem, you can use that motion interpretation in order to write that function. And now in part B, I'm asked to use this to evaluate f of 5 and f of negative 6. So all I'm doing for f of 5 is I'm just plugging the 5 in for the x. So we're going to say f of 5 equals f of 2 plus the integral from 2 to 5 of f prime. And what I have sitting over here is the graph of f prime. So to evaluate my integral, I'm going to take an area approach. I'm going to find the area from 2 to 5. From 2 to 5, and I've already done that over here. It's just a triangle, so 1/2 base times height. So the value of that integral is just a 3. So f of 2 equals 3, and the value of the integral also equals 3, and 3 plus 3 gives me my answer of 6. And I'm also asked to evaluate f of negative 6. It starts out the same way by just replacing the x with the negative 6. But what I see when I do that is that my limits are reversed. So what I'm going to have to do is put them in the correct order. So the negative 6 belongs as the lower limit and the 2 belongs as the upper limit. I know in order to make that switch, it's going to throw a negative in front. So that's where this negative comes from. My f of 2 is 3. Now to calculate this integral from negative 2 to 6 of f prime, I go to my graph of f prime, and from negative 6 to 2, I have a 4. This portion that falls below the x-axis gets counted as a negative. So my integral is going to be 4 minus 2 pi. I would advise leaving it just like that. This is a perfect final answer. If you wanted to simplify and distribute that negative, you could get it all the way down to 2 pi minus 1. Part C wants f of 4, f prime of 4, and f double prime of 4. The first part is just what we did in part B. So here's my f of 4. I just use that formula that I developed in part A. Replace the x with a 4. And then to evaluate the integral, I'm just finding the area from 2 to 4 up here. So I have to take a little piece of that triangle out. And I get my answer is 5.5. For f prime of 4, since this is the graph of f prime, all I'm doing for f prime of 4 is simply giving that function value. So I can see that at x equals 4, the function value is a 1. So f prime of 4 is 1. The next question in part C wants f double prime. And if I'm looking at the graph of f prime and I want f double prime, that is asking for the slope of f prime at x equals 4. So at x equals 4, I just count this slope right here, just a rise over run. I go down 1 over 1. So my slope is a negative 1. And a horizontal tangent is just where f prime equals 0. So I can look at my graph of f prime and I can see that f prime equals 0 at negative 2 and 2. So that is the first part of the question, to say f prime equals 0 at negative 2 and 2. And then I'm asked to classify each one as a relative min, a relative max, or neither. And I can see at negative 2 because f prime goes from a positive value to a negative value. That makes x equals negative 2 a relative max because f prime goes positive to negative. And when I look at x equals 2, I can see that f prime goes from a negative value to a positive value across that number. So I know at x equals 2, well, we have a relative min because f prime goes negative to positive. And also because this is an open interval, I don't need to worry about those endpoints as I'm declaring these maxes and mins. In part E, I'm asked to find the absolute max and absolute min on the closed interval from -6 to 5. There's a couple of key words in here that tell me what to do. An absolute, anything, whether it's a max or a min, along with a closed interval. I'm told it's closed, but also these brackets indicate that as well. Tell me that what I need to do in part E is a candidates test. The candidates table gives me a short list of possibilities for absolute max and absolute min. What belongs in that table are the critical points and the endpoints. So my critical points are just where f prime equals 0, and I saw that was at -2 and 2. And also the endpoints belong in this candidates table. So I have a short list of 4 possibilities for absolute max and absolute min. Because of the extreme value theorem, I know on this closed interval I'm guaranteed to have an absolute max and absolute min, and it's going to be one of these 4 values. What's going to determine which of these is the absolute max and min is the f of x value at each one of these points. The highest one will be the max and the lowest will be the min. So I need to find f of each of these 4 values. Some are easier than others because I've actually found some of them. F of -2 I haven't found, but I'm using that formula that I wrote in part A and just plugging in -2. I have to do the little switcheroo thing with the limits to get them in the correct order, which makes that a negative. And then I just find the area from -2 to 2. Because that area is falling below the x-axis, it's a -2 pi. And I get that that value is 3 plus 2 pi. So it's a 3 plus 2 pi. To find f of 2, well, that's an easy one because I'm told in the stem of the problem that f of 2 is 3. The next 2 are easy as well because in part B, I was asked to find f of 5 and f of -6. So I just need to pull those values down. So I'm just looking at these values and I can see that the biggest value is 3 plus 2 pi. So that's my absolute max. So I just write a little statement declaring that. And looking at these 4 values, I can see that my smallest value is the 3. So that's my absolute minimum value. And that occurs at x equals 2. The next several questions will take us through what the fun chart summarized for us. Part F wants to know on what intervals is f increasing and the intervals where f is decreasing. So I write this little part of the fun chart. I know that f is increasing where f prime is positive, and this is an f prime graph, so I need to make that connection. This graph of f prime is positive when the graph is above the x-axis. And that occurs on the intervals from x equals -6 to -2 is one of my intervals, and then again from 2 to 5. My reason is just because f prime is positive. So you could say that is an inequality, so it would be acceptable to say f prime is greater than 0. You could say f prime is above the x-axis. You could say f prime is positive. If you want to use the symbol and say positive, that would be fine as well. And I also know that f is decreasing, where f prime is negative. If you're a fun chart user, you've got it right here. So f is decreasing, where f prime is negative. And in my graph, that's where f prime dips below the x-axis, which occurs from x equals -2 all the way to 2. So that is my interval where f is decreasing. And my reason is just because f prime is negative. In part G, I'm asked where f is concave up and where f is concave down. And again, I'm given this f prime graph to work with. So I know f is concave up, where my f prime graph is increasing. So I take a look at my graph. And I can see that this graph is increasing all the way from 0 to 3. So that's my interval where f is concave up. And my reason is exactly what I was looking for, is where f prime is increasing. I know that f is concave down. Here's my concave down shape where my f prime is decreasing. And from my f prime graph, I can see that f prime decreases all the way from -6 to 0. And then again from 3 to 5. So those are my 2 intervals. -6 to 0, 3 to 5, and my reason is just because f prime is decreasing. Part H is asking me to put 2 of these characteristics together. I need to find where f is decreasing and also concave up. F is decreasing where f prime is negative, and f is concave up where f prime is increasing. So what I'm looking for is where f prime is negative and also increasing. Negative means below the x-axis, so that limits me to these points right here, and also increasing just narrows it down to this blue part. So that would be from 0 to 2. And my reason is just what led me to that interval to begin with. F prime is negative and increasing. In part I, I'm asked to find points of inflection on the graph of f. If you use our fun chart, that point of inflection is happening in between these two columns right here. So f has a point of inflection, that is a change in concavity, where f prime goes increase to decrease, or the other way around. On our graph, it's where this changes colors because this is all decreasing, switches to increasing right here. So that color change indicates a point of inflection at x equals 0. And another one when this goes from blue to red, here at x equals 3. And my reason is just that. It's where f prime goes increase to decrease or vice versa. Make sure in all of these explanations that you reference this f prime graph. Notice in all of these, when I get to my reason part, I have mentioned f prime in each and every one. Do not say it, do not say the graph. Always mention the graph by name. In this case, that graph is f prime. In part J, I'm asked to find f double prime of various values. And what f double prime is referring to is just the slope of f. It's just going one more derivative or slope out. So if I want f double prime of negative 5, I can just count out the slope. I go, here's negative 5 here. I go down 2 and over 4. And that gives me a slope of negative 1/2. F double prime of 0, here at 0, because I'm hitting that minimum point, I know that the slope of the tangent line would be a 0. So f double prime of 0 is 0. And at f double prime of 2, here at 2, I have a corner point because there's abrupt change in that slope. So therefore, f double prime does not exist because f prime has a corner point, and you can't differentiate at a corner point. In part K, I'm given a function g of x is x times f of x. I'm asked to write the equation of a tangent line at x equals 2. And I know to write the equation of a tangent line, I need to know two things. I need a point and a slope. My point is going to be g of 2, and my slope is going to be g prime of 2. To find g of 2, I just turn all my x's into 2's. And now I'm doing 2 times f of 2. In the very beginning of the problem, I was told that f of 2 is 3. So I just plug that in, multiply it by 2, and I get my point g of 2 equals 6. For my slope, I need g prime. So I'm going to have to do the derivative of my function g. Because I'm multiplying these two functions together, I know I need to do a product rule. So I'm going to go through my product rule. There is first times derivative of the second plus the second times derivative of the first. And after that, I plug in my 2 for those x's. And I calculate, and I get my slope is 3. And with this as my point, 2, 6, and my slope of 3, I write my equation. So y minus my y coordinate equals my slope of 3, and then x minus my x coordinate. Part L wants to know the critical values of h, and it's defined this h of x as being f of x minus 2 of x. We need to know what a critical value is, and that is just where h prime equals 0 or undefined. So I need to find the derivative of h. When you have an addition or subtraction, you just do term by term. So derivative of f is f prime. Derivative of 2x is the minus 2. I set that equal to 0 because that's how you find a critical point. And when I solve that, I get f prime of x equals 2. So I just go back to this f prime of graph. If I want to know where f prime equals 2, here's my f prime graph, I can see that this equals 2 at two places, right here and right here. So at x equals negative 6 and x equals 3 are my two answers. Part M is asking me to find the average rate of change of f prime on the interval negative 6 to 5. So I just use that average rate of change formula for f prime. So f prime of 5 minus f prime of negative 6 over 5 minus negative 6. To evaluate f prime of 5, this is the f prime graph. I'm just pulling the function value. So here at 5, my function value is the 0. F prime of negative 6, I look here, and at x equals negative 6, my value is 2, so that's my 2. And 5 plus 6 is the 11, so I get a negative 2 over 11. The next statement in the problem says there is no point C on the interval where f prime is equal to the average rate of change. And we know that the mean value theorem guarantees that there is a point where f prime equals the average rate of change. The reason that this does not contradict the MVT is because f prime is not differentiable at all the points on the interval -6 to 5. In fact, it's not differentiable at several points. So right here at the -2, the 2, and the 3, because you have a corner point. And that mean value theorem is only applicable if you have a continuous and a differentiable function. And our final question wants us to find the slope of the tangent line. We know that is code for find the derivative. To do the derivative of p, it is a composite function. This x squared minus 1 is inside of that f function, which means I must engage the chain rule on this one. So the chain rule says I'm going to do the derivative of the outer function, which is f prime, leave the inside alone. So my x squared plus 1 stays the same, times derivative of that inner function, and the derivative of x squared minus 1 is the 2x. If I want to evaluate it at x equals 2, then all of my x's are now going to turn into 2's. So this becomes f prime of 3 times 4, and f prime of 3, from the f prime graph, it's just pulling that function value, which is 2, and that gives us our final answer of p prime of 2 equals 8. The AP exam on a graph analysis question might ask you 4 of the previous 14 questions that we went over. So if you're good on all of those, you are pretty much covered on graph analysis.